All right. So with proofs, there are a couple ways to do it. So the first way is a flow proof, which in some ways are one of the easiest ways. The second way is kind of just like a T-chart, where the statements are on one side, the reasons are on another. So the way a flow proof works is that your statements are what's in the boxes. All right. So all of these are statements, and your reasons go below it. All right. Now, here's how this works. So, when you're given a proof, there's always two things that always happen when you're given a proof. All right. You are given some conditions that have already been met. All right. Those are like given statements because if you don't have a given, it's near impossible to get started. All right. So they usually give you one or two statements that they just give you to get you started. All right. Now, just move it. Put it back. So, if you see these reasons right here, so like this one and this one, the reason is actually just given because they gave it to us. There's no other reason besides they gave it to us. So that's how we know it's true. And then it asks you what you want to prove. All right. So that's your end goal of when you prove. So with proofs, there's no like strict procedure for how you prove something. It just has to make sense logically. That's the hard part about proofs is it's kind of hard to figure out where you can start because one proof may look different than the others. Now, luckily in this class, I'm not going to make you write a proof strictly from scratch. All right. So like, you have to know all the statements, have to know all the reasons. Most of these will be fill in the blank for you guys. So in other words, I'll give you some of the statements and some of the reasons, and you got to fill in whatever's not given to you. All right. So like, for example, with this one, I gave you all the statements. We just have to go through the reasons. Now, when you start a proof, you always look at what you're given and then mark it on the shape. All right. So we're going to mark that angle H is congruent to angle E. So it's kind of hard to see, but this is H, U, R, S, and E. All right. So angle H, which is right here, is congruent to angle E. So I'm going to go ahead and mark those so I know that they're congruent. Then segment UR is congruent to segment US. So UR, so right here, is congruent to this one. And the goal, you then want to kind of give yourself a goal of how you're going to prove it or what you're trying to find. I like to either put like a small circle around it or a question mark just so I can prove it. So the goal is to show that segment HR is congruent to SE. All right. So in other words, we're trying to prove that these two segments are congruent. So I'm just going to draw a circle around them because there's no mathematical symbol to show. There's no mathematical symbol dealing with a circle. All right. In geometry, at least. Now, like I said, they already gave us the statements. So what they're saying is that if angle H is congruent to angle E, and side UR is congruent to side US, and angle HUR is congruent to angle EUS, then the triangles RHU is congruent to triangle SEU. So thus, triangle HR is congruent to triangle SE from CPCTC. All right, so that's where it says congruent triangles. What's the words? It means corresponding pairs of congruent triangles are congruent. All right. So in other words, it looks like we got to prove that these two triangles are congruent first in order to show that the sides are congruent. Because if the triangles are congruent, then of course the sides are congruent because they're corresponding sides of the two triangles. All right. Now, for the reasons, the easiest reasons ever are the ones that are given to us. So these first two reasons right here are just simply given. They gave us that information. There's no rhyme or reason for why that is, why they're congruent. They just gave us that information to get it started. So whatever your given is, that is part of your proof statements, but you just say that they're given. Now, that's part of how they showed that the triangles are congruent. So that's what the flow chart's for. The flow shows how they connect. So if we know these three things, that means that we can get this. And if we know this, that means we can get this. That's what the flow chart's talking about. Now, let's look at the third statement. Let's see if we can figure out what it's talking about. So, angle HUR is congruent to angle EUS. So let's go ahead and mark that. So angle HUR, so right here, is congruent to angle EUS. So right here. Why are these two angles congruent? What geometric property, you may want to look at that green graphic organizer, what geometric property tells us that those angles are congruent? Yes, ma'am. Not reflexive. They're not the same side. They're not like the exact same angle. Look at the shape. Looks like an X, right? On your geometric reasons, what reason does the angles look like an X and they're directly across from each other? So guys, literally look at the back of your graphic organizer. It's what? They're congruent. They already told us that they're congruent, but why are they congruent? They're vertical angles. So if we're looking at our green graphic organizer from yesterday, all right, so if we looked at our green graphic organizer from yesterday, this one right here, the one that looks like angles with X's, all right, they're called vertical angles are congruent. That's literally our reason for this. Why am I? So these two angles right here are vertical angles. And as we know, the reason here is vertical angles are congruent. That's how we would state that reason. Vertical angles are congruent. That's why that's true. Now, since we have all the reasons for kind of the setup, now we can show that these two triangles are congruent. Which triangle congruence postulate with the information that we're given? So these two angles and this side, which postulate shows that those two triangles are congruent? By what postulate? So is it side, 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 angle, side, angle, side, angle, 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 side? What do you guys think? Angle, angle, side. So in other words, these are congruent by angle, angle, side. That's all you got to say. And then, of course, if the triangles are congruent, that means that these two sides have to be congruent by CPCTC. Because these two sides are corresponding, meaning they're the same side of the same triangle, all right? And since the triangles we know are congruent, meaning same size, same shape, those sides have to be congruent. All right, does that make sense a little bit? So the biggest issue with proofs is trying to figure out where to start and then trying to figure out the reason that describes it.
So that's why I gave you all those references to look at, because those references will help you figure out the why. The whole part about proofs is that they don't so much care about the what. Like, what is congruent, what is supplementary, whatever. They don't care about the what. They care about the why. All right. So the way I like to think about this is think about a cop show. All right. So who's seen Blue Bloods before? Or Brooklyn Nine-Nine? Or The Rookie? All right. What all those cop shows have in common is that when it comes to proving someone guilty or innocent, most courts don't even consider it without enough evidence. All right? A crime without enough evidence, or convict someone without enough evidence. They don't care about what they allegedly did. They mainly care about why it is that they're being convicted of it. What here proves that they did it. All right? That's how proofs are. They give us the what we think makes it, but at the same time, we have to explain why that is. We have to get more details. So, for example, if, someone was convicted of, murdering someone, all right, and they got caught, a detective can't just say, well, we think it's this guy, so there you go. They have to say, okay, we know it's this guy because we found his DNA, which we got through DNA testing of the murder weapon or whatever. We found blood on his clothes, which matched that of the victim. We found blah, 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 blah. Like, there's a bunch of evidence and reasons why that the evidence is valid to convict. That's what it means. You're validating your statements with the reasons. Does that make sense? So that's the whole thing about proofs. We don't really care about the what, although the what is important. The why is the more difficult part. Why this statement is true. Why this statement works to what we're trying to prove. All right. Okay, so let's try another one. So still proving congruent triangles. All right. So this time they left some of the statements out and they still left all the reasons out. So first things first, we're looking at what we're given and we're going to mark it. So they tell us that angle UQA is congruent to angle DQA. So angle UQA, so right here, is congruent to angle DQA, so right here. So these two little angles are congruent. They also say that angle DAQ is congruent to angle UAQ. So DAQ, so right here, is congruent to UAQ. So UAQ is right here. Remember, when you're trying to figure out where the angle is, start at the first letter, go to the next letter, and then go to the next letter in a row. And then that's the angle where the angle is. So for example, UAQ, I would start here at U, go to A, go to Q. That means this is the angle I'm looking at. All right. And we're trying to show that angle U is congruent to angle D. So we're trying to show that these two angles are congruent. That's what we're trying to show. That's our end goal. Now, they already put in our two statements that they gave us. So what automatically are the reasons for this? Given. So automatically the reasons for the two statements that they did give us are given because that's just what they gave us. Now, this one we have to kind of think about a little bit. So, we already got two angles that are congruent. All right. We need to prove that either a side of those two triangles are congruent or that another angle is congruent. But we can't really prove the other angle because that's what we're trying to find. All right. But we need something else to prove that the triangles are congruent. Because remember, if the triangles are congruent, which would be this statement right here, What would the reason for this one be? So our end goal, we know our end goal is angle U is congruent to angle D. And what do you think the reason's going to be? CPCTC. CPCTC. Because we're trying to prove that these two triangles are congruent. So whenever you're trying to prove, like if you're given two triangles and they're asking you to prove that a certain angle or a side are congruent, prove that the triangles are congruent first. All right, because then from there your answer is just these are congruent because of CPCTC. So in reality, we're trying to prove that triangle QDA, and let me write that smaller so it actually fits. So triangle QDA is congruent to triangle QUA. That's what we're trying to prove. We're trying to prove that triangle QDA, so the top triangle, is congruent to the bottom triangle. But we don't know how yet. So look at our triangles. What would probably be the easiest piece to prove that it's congruent? What side or angle specifically would be the easiest to prove? QA. Why QA? It's a side that they share. So QA is a side that both triangles share. So we would state this that segment QA is congruent to segment QA. So we're saying that this segment is congruent to itself. What property allows us to do that? It's on your statements. It's the reflexive property. So this is by the reflexive property. Because they share that side. Now, how are these two triangles congruent? Angle, side, angle. We have an angle, we have a side, and then another angle. So this is congruent by angle, side, angle. So that means that what we're trying to prove right here, these have to be congruent by CPCTC. Because if the triangles are congruent, then obviously that last angle is congruent of the triangle that we don't know is congruent or not. Does that make sense for these two? So a lot of times you're asking yourself, okay, what would be the easiest place to start? Because, and you gotta think logically about this. So we know that we have two angles. So if we're already given two angles, what are the only possible postulates that we can use if we're already given two angles? Angle, side, angle, and so the only two postulates that will work if we're already given two congruent angles. The first one will be angle, side, angle. What's the other one that has two angles in it? Angle, angle, side. So then let's narrow it down. All right. For this one, we already know it's angle, side, angle. But if we want to do angle, angle, side, that means that we would have to either prove that these two sides are congruent or these two sides are congruent. Is there any possible way that we could logically prove that? No, there's no like features that we have that could help us with that. It's not like we can use like parallel lines or anything like that. There's nothing that gives us that way. So the only thing that we can do is prove that this side is congruent. Because remember, we can't show that this angle is congruent because angle, angle, angle is not a congruence postulate. All right. So we would have to prove that this side is congruent. So that's just a way that you can logically think about this. All right. Ask yourself, okay, they gave me that two angles are already congruent. That narrows it, and I need to prove that these two triangles are congruent. That narrows it down to two postulates I can use. Which one would make the most sense to prove? That's what you're asking yourself. All right.
Angle side angle was the only reasonable one that made sense to prove because they shared that side. They have a property that can answer that question of why that would work. All right? So remember, when it comes to proofs, think court, innocent until proven guilty. All right? We can't prove that these two sides are guilty of being congruent to each other without enough evidence. And there is no evidence that we can show to show that those sides are congruent to each other without knowing that the triangles are already congruent first. This side, however, we can show they're congruent without knowing that the triangles are congruent first by the reflexive property, which means that it's the same side that they share. Does that make sense? That kind of put it a bit more in perspective of how you start these. All right? So now what we're going to do is I want you to take out Desmos, Delta Math, and go to where it says 5.2 intro to proofs. We're going to do some together. So we're going to do some more practice of this, but we're going to do some more of these together. So I would keep the graphic organizers out, and you may want a piece of paper to write stuff down just so you can have notes. Because trust me, they only get harder from here. So please, 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 please write these down. So I'm in Delta Math, and you want the one that says 5.2 Intro to Proofs. We're going to do the single problems together. It's on my desk. Like, it's right on my desk. You can't miss it. All right. So once you get to Delta Math, pull up the very first problem, which is a single problem, so it should be the same for everyone. Okay, so I'm shrinking it just so you guys can see the whole picture. But obviously you'll be able to see it clearly on your laptop. So, Delta Math is pretty nice about how they do proofs because they may either already give you the statements or the reason, and then they give you drop-down menu of what to pick from for the reasons. All right. So, let's just kind of work through these together.
You said 1.5.2
into the proofs.
Okay, so let's copy out the examples.
All right, so now Desmos doesn't flat out state what they gave you, but they do mark it. All right, so they're given it's what's already marked on the graph. So let's look at what they already marked on the graph. So the first thing that they say is angle BAC is congruent to angle CAD. So BAC is right here, it's one of the ones they already marked, is congruent to DCA, which they already marked. It's right here. So what do you think the reason for this one is? They already marked it for us. It's given. Since they already marked it for us, that means it's a given. So for this reason, you put given. They then say that angle B is congruent to angle D. So angle B is right here,
and angle D is right here. This is one that they already marked for us as well. So what's the reason? Given. Now, they then say that side AC is congruent to side AC. So right here, what makes that congruent? Reflexive property. It's the same side. So for this one, you would scroll down until you see reflexive property, which shouldn't be very far down. Now, so how are those two triangles congruent? What postulate? Angle, angle, side. All right. So this one was particularly easy because they already gave you all the statements. That's not always going to be the case. All right. Sometimes they give you a mix of statements and reasons. So this is angle, angle, side. All right. Sometimes that's not always the case, but in this case, they gave us all the statements. Sometimes they give you a mix. They give you like some of the statements and some of the reasons. Sometimes they don't give you any of it besides the given. All right. Now, the reason we're going through triangle congruence is because later we're going to do quadrilaterals. And quadrilaterals rely fairly heavily on congruent triangles as well. All right. So if you know how to prove a triangle, you can prove a quadrilateral. All right. Everyone go with this one.
Yeah.
So again, Desmos does not actually state whether it's given or not. They just mark the triangle. So just know that if they mark it, why do I keep saying Desmos? Delta math, if they mark it, it's given. All right. So let's go to the second one. So this second one, they actually state that angle AC bisect or side AC bisects angle BCA. All right, so let's just go ahead and mark that. Or actually, they already did. So this side right here bisects this angle, meaning what? It cuts it in half. So that means this tiny angle is congruent and this tiny angle is congruent. So where we start is always our given. So what's our statement right here? So just tell me, what would our statement be? Don't look at the drop down. What would our statement be about this given? So angle BAC is congruent to what angle? Make sure to state it including the corresponding. So where do you start for the corresponding with BAC? So if I start at B over here, that means corresponding of this triangle, I start at which letter? D. DAC. So we're going to say angle BAC is congruent to DAC. Oh, no. First, we're going to state that angle XY, or side AC, like you guys said, and I didn't listen, side AC bisects angle A. Or, no, BCD. I marked the wrong angles. Crap. See, even I make mistakes. So, okay. So when you drop down, you're looking for what the statement is like you want. So it'll say like something like segment XY bisects angle X. All right, so you pick that and you put the type in the sides. Yeah. So angle AC bisects BCD. And make sure you use capitals when you have to use capitals. And the reason is it was given. That's the only reason we have for this one. So again, this side bisects this angle. All right, that's what I marked wrong. So that means that these two are congruent. Now, once we get there, what directly corresponds to that side bisecting that angle? What information do we get from it? So the next part of the flow chart, the reason that goes, the statement that goes directly below this one is basically how does the bisector affect this angle? What does that mean? It bisects, which means it does what to the angle? It cuts it in half. So in other words, we can say that these two little angles are congruent. So how would I say it? How would I say that these two little angles are congruent? Like, what statement would I write? BCA. So BCA is congruent to DCA. And that's exactly what you would type. And what's the definition? And what's the reason for this one, do you think? So how do we know that those two angles are congruent? What told us that? What gave us that thought? The bisector. So in other words, it's the definition of a bisector. That's the reason. Definition of a bisector. Or angle bisector, or however they say it. All right? So, remember, they got to relate back to each other. That's kind of why flow proofs are nice. You can see how they relate back to each other, which ones don't relate at all to each other. In this case, this one relates back because we're saying that angle BCA is congruent to angle DCA. And the reason why is that an angle bisector divides an angle into two congruent angles, or definition of angle bisector. That's why. Now, the last two reasons are easy because what they already marked for us. So what's one thing that they already marked for us? So they already had that side BA is congruent to DA. So if they already had it marked, what's the reason? Given. What else? What else did they mark? Right, angle BAC is congruent to angle DAC. Again, they just marked these already for us. So that is what reason? Given. So that's exactly what you would put in for these two boxes here. So these two boxes, it doesn't matter which order you put them in, you'll write these two statements, and this is the reason. All right. So I would say that segment BA is congruent to segment DA, and I know that because it was given. And then angle BAC is congruent to angle DAC, and again because it was given. And then that shows the reason you can prove those triangles are congruent is by angle, angle, side. They already gave that to us. So in reality, the only thing that wasn't given to us was this right here. And that's how we know that it relates back. All right. Because if we're saying that AC bisects angle BCD, that means logically that whatever angle we cut in half, those two little angles that are formed because of that are congruent by definition of an angle bisector. And then we have our two given reasons, which then with our postulate would give us two angles and a side that are congruent. All right. Are you guys following at all? We're just going around.
I understand it, I just can't see the.
So I wrote it right here. Drop down, so it should say like angle X is congruent to angle Y. So it should look like, so it looks like this, Corey.
Yeah.
All right, any questions on this one? All right. Now let's look at a short proof where they actually don't give us a triangle congruence. So this one actually has some quadrilaterals in it. So this one, we actually got to do some logic here. So we're trying to prove that angle B is congruent to angle D. So our angle to prove that these two angles are congruent. The only thing that they gave us was that side BC is congruent to side AD. So these two, not congruent, parallel. These two are parallel. And then AB is congruent to CD, and these two are parallel. And they already stated are given. So let's think about this logically. If we know that two sets of sides are parallel, what type of shape do we have? We have a parallelogram. So in other words, the shape BCDA or quadrilateral, we know it's a quad, quadrilateral BCDA is a parallelogram. And the reason is that a definition of a parallelogram? Two sets of congruent sides? Look at our hierarchy. That's the definition right there. It's a definition of a parallelogram. So that's our first statement and reason. So we're going to look at the statement and we're going to scroll down till we see do we have to do something before? We're not classifying a triangle. Can we just state that? Oh, duh. Okay. So we're actually not looking at it in sense of a quadrilateral. All right. This also goes to show, look at the statements before you start. That's one way we could have proved it. Here's another way. So if we have two sets of parallel lines, if we draw these, what does this look like? What would these two angles be? Alternate interior. Because if we then had, so let's say we took away these two parallel lines. If we had the transversal here, which is that diagonal, Well, actually, it makes sense for these two lines. So in other words, if we had these two lines, these angles here, and they're cut by that transversal, all right, they're what type of angles? So first off, are they inside the parallel lines? Are they opposite each other on different sides of the transversal? So they're what? They're congruent by alternate interior. So we can flat out say that angle B is congruent to angle D with alternate interior. So that's why it's so daggone short. So we can say that angle B is congruent thusly by angle D because, and you got to read these carefully. Parallel lines cut by a transversal form congruent alternate interior angles. Hit try. What? Not alternate interior. Okay, I know what we gotta do. Okay. See, this is why I hate freaking proofs. Alright. So we can't quite show that B and D are congruent yet. We can show that two other angles are congruent, and that should give us, we can show that two different sets of other angles are congruent, and that should give us enough reason to prove that these two angles are congruent. So first off, we first got to prove that these two triangles are congruent. All right. What's one way that we can prove that the triangles are congruent? AC is congruent to itself by the reflexive property. So that's the first thing. We're going to say that AC is congruent to itself by the reflexive. Yes, you can use the restroom. All right. So AC is congruent to AC because of the reflexive property. That's valid. Now, we can then use the parallel lines to our advantage. So I just proved that these two sides are congruent. Now, if I drew a set of parallel lines, so using these two lines, and the diagonals are transversal, what are two angles that I can prove as congruent based off parallel angle properties? So within this rectangle, that means we're looking at interior angles. So we're looking for what type of angles for them to be congruent? Alternate interior. Which angles are congruent that I can prove that are congruent? BCA and CAD. We can prove those because they're alternate interiors. So angle BCA is congruent by angle D angle DAC because they're alternate interior. All right, so we can show that. So these two angles are congruent. So BCA is congruent to DAC because two angles, parallel lines cut by transversal form congruent alternate interior angles, which is true. Now, from what we're going with, if we're trying to prove convergence, what other two angles do I need to prove that are congruent? So we're trying to make the two triangles congruent. So what's the last thing I got to prove congruent to get a solid postulate? Not B and D just yet, because that's what we're trying to prove. But we got to prove congruent triangles first. So we got these two angles, and we got this side. So what does this look like it's going to be? What postulate? I'm thinking this is going to be an angle side angle. So I have an angle and a side, so what other angle do I need? So I need this one, and I need this one. And these two are congruent because why? Alternate interior. So angle BAC is congruent to angle, guys, stop talking, DCA, and again, because they're alternate interior.
No, I'm saying. The third one says parallel lines cut by a transversal.
And again, that's because alternate interior angles are congruent. So now we can say that the two triangles are congruent. Why? So triangle ABC is congruent to triangle CDA. Why? What postulate? Angle side angle. So now, since we proved that the triangles are congruent, that means that angle B is congruent to angle D. Why? What special form gives us the angles in the side? So if we know that the triangles are congruent, that means those last two angles have to be congruent because of what? CPCTC. And we're done. So guys, if I was trying to prove with a quadrilateral, I would have, the easiest thing. So sometimes delta math wants you to kind of go around your butt to get to your elbow. But if they told me that this is obviously a quadrilateral, and they told me that two sets were parallel. So if I were to prove this on my own, I would have said that BCDA was a quadrilateral because definition of quadrilateral has four sides. Then I would have said that BCDA was a parallelogram because definition of a parallelogram, two sides, two sets of parallel sides. And thus, B and D would have been congruent because opposite angles of parallelograms are congruent. That would have been the shorter way, but again, delta math wants you to go around your butt to get to your elbow. Yes. Yeah. CPCTC. All right. Couple more, and then I'll kind of let you guys loose. We'll do a little bit more proofs tomorrow. Yeah, go ahead and take 5. Yep.
Angle B is bigger than angle B.
CPCPC, yeah.
Dang, I did not draw.
We probably forgot something.
Actually, I can't even get to this question. I can't see them. But that's what that is when you know. Or it's gonna be one point. It's easy. Okay, we'll do this one.
All right, guys. So I'm on the very last single problem on the delta map. This is the very last one. All right. So what I'm going to do is I'm going to write the stuff that we come up with on the board, and then y'all just fill it in. All right. That might just be a little bit easier. All right. So I'm on the very last one in delta map. All right. The very last problem. So now we're in quadrilateral land a little bit. All right. Now with quadrilateral proofs, there's a couple things that you're proving. You're either going to prove that, some sides are parallel. You'll prove that it is the type of quadrilateral that it is. You can prove that triangles formed inside of it are congruent. There's a couple of different things you can prove with quadrilaterals. So the first thing they said is the shape ABCD is a parallelogram, and that AF is congruent to CG. And we're trying to prove that triangle AFE, so this triangle right here, is congruent to this triangle right here. So before we even start making statements, let's just make a plan of attack. All right. We know that this is a parallelogram. This entire shape is a parallelogram. And we know that these two sides are congruent. All right. Let's just think for a second what would be the easiest to prove. All right. What is any angle or side within these that would be easiest to prove? Say that again? So FEA and CEG. We could do that one, but then we'd have to either prove that another angle is congruent, or we would, because we can't prove another side is, well, we could. No, we couldn't. So we prove this side, we end up with ASS. We prove this side, ASS. So we would have to prove that another angle is congruent. Either get angle side angle or angle angle side. All right, it is doable though. We could also prove that another side is congruent and then an angle. I would go for, so if we want to prove that these two angles are congruent, that means we need to prove that these two angles are congruent, which is totally plausible, all right, given what we're given. So what do you think our angle is going to be? How are we going to prove this? By what postulate? This will be what? Angle, angle, side. All right. So now, let's make a plan of attack to get what we need first. So first off, what would be the easiest to prove that we can already state are congruent just off the bat? Which of these two angles can we say are congruent just off the bat? Angle AEF is congruent to angle CEF, or CEG, sorry. Why can we say that? What's special about those two angles? These two angles right here. They're vertical. So the reason is vertical angles are congruent. So that one's easy. But now we got to think about how to prove that these two, all right, are congruent. Let me ask you this. They told us that this was a parallelogram for a reason. Why do you think they told us it was a parallelogram? Why does knowing that it's a parallelogram matter? I'll give you a hint. It helps us find these two angles. What do you think? Not so much that. What's true about parallelogram? It has what? It has two sets of parallel sides. Isn't it not true that if I stated that these two sides are parallel by definition of parallelogram, that I could get these two angles congruent by alternate interior? That's right. So first things first, we gotta state the before we can say that these two angles are congruent. We have to say that these two segments are parallel by definition of parallelogram. So we say that side BC is parallel to side BA. And the reason is that's just a definition of a parallelogram. Or I think it'll say something like opposite sides of a parallelogram are parallel, something like that. Is that what it says? Yeah. So in other words, opposite sides of a parallelogram are parallel. Now we can say, it doesn't say anything about transversal, right, in the statements? No. Okay. So now we can say that those two angles that we tried to prove that were parallel, not parallel, congruent, are congruent. So angle FAE is congruent to angle GEC because alternate interior angles are congruent. Does it work? Did that work for you guys when you tried it? It did or didn't? I think it's like parallel sides cut by a transversal, alternate interior angles are congruent, something like that. It didn't work. Okay, so we need to prove another step. All right, so we got to prove that something is a diagonal. No. Give me 1 second, guys. No, they're alternate interior. Do we also got to say that? Okay. So also say that DC is parallel to AB. DC is parallel to AB. And again, opposite sides of a parallelogram are parallel. Now we can say that those two angles. See, delta math is finicky. Like I said, go around your butt to get to your elbow. No, we've proven enough. What the heck? Okay, so these two are parallel. Okay, let me try something. So let's go for, because we know all the diagonals of parallelogram bisect. So let's go that route. So BD bisects AC. And the reason is, again, it's just diagonals of parallelogram bisect each other. So that means that AE is congruent to EC. And the reason that is because segment bisector divides the segment into congruent segments. Thus, angle AFE is congruent to angle CGE because, where is it? If in a triangle, angles opposite of congruent sides are congruent. So those two angles have to be congruent. So, you see why I hate proofs, guys? I won't take this one, but there's another one that you'll do, and that one you'll have to. I have to take something as a grade. All right. May just be a participation grade. All right. No, I'm mad now. I got to figure it out. So. No, that won't work. So, nope. It's on the EOC. They would just ask you for a reason why that statement works. That's the only thing that they ask.
Is it multiple choice?
Yes, as in multiple choice.
This better be, you better give me like four options for reasons. Four options and one answer.
So now can I show that it's angle side?
Guys, this book is fun.
So let's say angle F A E is congruent. Now it works? Okay.
Wow, me too.
So then now the triangles are congruent by angle, side angle.
Same.
Jeez, that took way more work than it was worth.
This is why I failed every math class. This is why I barely passed. I like how Miss Murphy, the teacher who does. She's struggling.
No, I get it, but Delta Math is so finicky with what they
And
want.
you have to put it directly in a certain order. What if I just like, no.
Okay, so that one was. So guys, type this in exactly. I'm about to. Give me a second.
Can you zoom my eyeballs? I can't see anything. I wish Zoom was like a function on my eyes. Like that would fix my eyesight instantly. If I could zoom into things, I'd be fine. What do you mean?
You know what the irony is? That entire thing that I was talking about that was cut in the video. It's fine. All right. So put that in.
Mine's the window, so you don't open it.
She explained this.
Are we no longer opening the window?
I wasn't in here, actually.
It's too humid outside. It'll only make it worse in here.
Actually, no, you explained it to me. I didn't hear anything you said. I was listening. Yeah. I'm throwing shame.
Why did I have to show that those two segments were congruent? No, I guess I did have to.
Ever so slightly more.
And so slight.
Dang, I'm so blind.
I clicked off.
Thank you. Chat. I can barely see it.
Shut up.
Maybe you shouldn't sit so far back.
I mean, sitting up close enough. I'm just dumb. That's the difference. Shut your face hole.
I got it.
Miss Murphy. This thing's stupid. Oh, wait, never mind. I'm a liar.
Give me mine, they.
Cut?
Yes,
I don't freaking know. Like I said, Delta Math hates us. All right. I forgot why these make me mad because, you know, if I was asking you to prove it, if I said what I said earlier, I take that because that's valid. But Delta Math wants you, like I said, go around your butt to get to your elbow. So
Wait, let's go back up, please. I'll cry.
Yeah.
What is that fifth one say?
They bisect each other. The diagonals of a parallelogram bisect each other.
Right again. That's not right.
The right thing, right? Or am I done?
Mm-hmm.
Dang, why is it not working?
That's what I said. I'm putting the right thing and it's not working.
I can't see.
Guys, I'll give you credit for it either way. We did it together as a class. I don't care if it's perfect.
Hers? I don't care if it's
It's
perfect.
so right.
Dang, it won't let me
It's
submit
number
it.
7 and it is like typed in correctly. But
It's
Is the statement correct?
yeah.
I don't know then. Like I said, Delta Math is a. I'm not gonna say it.
I'm about to give you language in this class.
let me do it.
You don't have no problems.
Okay.
I'm gonna set my Chromebook on fire.
No, I heard a story yesterday. My mom was telling me. My dad went to this high school like years ago, right? And my mom, I asked her, I said, did Dad graduate? She goes, no, you didn't know that? I go, wait, why didn't you graduate? And she tells me this story about how he tried to light up the school and he got expelled permanently from every single school. and he went to jail for like 6 months because of it.
Committing arson and then getting jailed and never being able to go to school again is crazy work. That is so wild.
Mind you, this happened years ago, but like, I found out yesterday. I didn't know this until yesterday. I thought my dad graduated. He did
Yours is
not.
broken, I give up.
You know what's weird? My grandma didn't graduate school, but she still had a restaurant.
Did she own it?
Yes, it's hers.
You don't have to graduate.
You don't have to.
own.
You also can go and get a GED,
And even if
which
you-
is basically the exact same thing as a high school diploma nowadays.
I mean, she doesn't have a GED.
I don't think
If you started your own
needed it.
business, you don't really need it.
I mean, she had a billiards, she sold alcohol, and she had a restaurant. It was a fire restaurant.
But yeah,
She took some
I
fire
was
to
shocked
it.
when my mom told me he tried to light up the school.
Trying to set school on fire, like me personally, I could never. But y'all got that though. That's on y'all.
It was like my dad and like this one other guy. They went in the bathroom,
So many
put
bad.
something in the toilet, and then
Whoa.
tried to light up whatever was in the toilet. And it didn't work very well because they got caught. But
I mean, kids do that now though. They might get expelled.
on one of the hallways, I think it's the English hallway, it says you can't come into this bathroom until behavior changes.
Oh my gosh, I have a picture of it. They put tape over. It's the English hall bathroom.
Yeah,
the
it
boys'
is.
bathroom. They put tape over the door frame because there's no door already, and so they put tape over the door frame and put
And
a
it's
picture
like-
up, and it says "closed until appropriate choices can be made." Yeah, I think it's
Like,
so
bro,
funny.
I think
I
it's
think
what do
it's
you
just
mean
an
appropriate
really-
choices?
I think it's
It's
so
not
funny.
even like that.
It's just the way they worded it. Appropriate choices. is hilarious.
The,
Like what kind of choices?
Like, what were they doing in
What
there?
were they
Like,
doing
do
that
you-
was so bad? Like they got their bathroom privileges taken away.
Miss Edwards told me what they did. That's
What
why
they
went to
do?
the door. They used to like.
So guys, just keep working through it like the rest of this Delta math. Just try it. Because some of them are easier than others. That one was just a doozy, but I'm trying like the second one from the bottom and it's actually really easy.
It's really easy. You're a math teacher.
Well, it's really easy if you know the properties of a square, which you should.
I mean, you got that.
Should.
You got that. That's all you need.
Now my mom is like, my mom just left the house.
Don't say forever, because
I just proved that all the sides are congruent.
now it's more
You could try.
Oh, I proved the wrong triangle. Okay.
She says that so casually. Oh, it's a triangle. That's perfect. Who are you? Why is he coloring the whole notepad black?
Bro, my
Okay, let's go.
boyfriend's like,
Ugh.
I got checked out.
For why?
Now the triangles are congruent. By side, side, side.
It was really popular.
I'm a little afraid of
That's me.
Miss Murphy, I'm scared I'm gonna fail just because of this portion. Miss Murphy, he has no words for it. He feels the same way.
I don't think there's a lot of this question.
No, I think math reason is not graduate.
If I don't graduate this year specifically because I don't understand proofs, I'm gonna be so mad.
It ain't gonna be that big of a deal. There's like maybe one question on the EOC that has that.
Okay,
But like, gang, it's not even like that. I can't do proofs.
I can't do math.
And literally on the test for this class, I'm just gonna ask you to give me the statement or
Is
the
it?
reason.
And the EOC was
EOC.
I already took it once.
math too, but a teacher made.
That's super fun.
I had like an average of like a 56 in math class.
I only passed my math too because the teacher made me.
I still don't know.
I failed math once twice. I failed math two once.
Only twice. I failed 3 times too.
Well, I failed it twice, had to take it.
I to take my math teacher
Did you
circle
do credit?
in like bold. Math one foundations.
That's okay. This semester I have to take credit recovery for English 3, which I don't want to do.
I want to do just one line.
And then I have to take English 4 on top of
Exactly.
it.
I had to take math 4, and I'm not ecstatic about it. I'm actually really mad. I didn't know foundation was an option. Nobody told me.
Oh. Nobody told me either. I thought
They just put
I
me in
yeah,
it.
it just got put in there.
They just put me in it. So this is my last math. If
Finally.
I pass this math, I'm really sorry.
Well, according to my middle school, I excelled in my programs. I only excelled because I had an IEP, and then they took that away.
Me too. But now I'm middle school. And then they took it away.
Okay,
I've had one my whole life, and they're just like, no.
You
Not
didn't
anymore.
color an entire milk carton black. I did. Except for one spot. Sorry. And then like
I'm gonna tweak. I still make you I tried to get my IEP back, and they're like, no. What do you mean no? Like,
Because you have to be tested, and if you don't meet the requirements, you can't have one.
but I've been tested before, and I did.
But you get retested, so if
I
you're
never got retested though.
well, then that's something different then.
Yeah,
There was no
they
questions
suck.
asked. There was no like, oh well. It was just gone.
Well, once you get to like high school level, they expect you to ask.
I asked, and she was like,
No.
what?
Okay, guys, so I gave you a really easy one for your exit ticket. Basically, all of it's given to you already. You just gotta tell me why this reason is true, and then why these triangles are true. So you already have the statements, you just gotta give me the reasons. And I already told you that these two were given. So why is BEA congruent to CED?
My head hurts. This is too much. I give up.
So guys, here's a freebie for exit ticket land. Why are these two angles congruent? They're vertical angles. So this triangle is congruent by
Vertical angle.
Angle side angle.
angle side angle. So there you go.
Hey Maggie, show me my information.
You're welcome. You're welcome. God bless. It's fine.
God bless, it's fine. I'm gonna film that for you.
My head.
You're not gonna fail math 3.
I'm
Well,
gonna
just
film
do all the extra credit. You're fine.
I do. I mean, sometimes. I do sometimes.
I do it.
I do.
I'm shaking her. She's like, come on. I did it one time. It didn't help my brain at all. So.
Supposed to.
Well, no, I did it, right?
Video game.
It's hard. You didn't check my accident.
Did you check
We
any
literally went over that.
We went over that.
I wasn't in here, guys.
Okay.
Oh, yeah, that's right. I was talking to my counselor about being harassed by a random guy I don't know. I literally got harassed by a random guy I don't even know. Guys, leave me alone.
So guys, try your best to finish that one. If you don't, it's okay. I won't take that one as a grade, but you still need to kind of practice it a little bit. We'll do some more specifically with quadrilaterals tomorrow. That's a different delta, but it's not terrible.
What if I cry?
Is this on our test?
Yes,
Oh. What is this whole unit about?
quadrilaterals.
What's that?
That's not quadrilateral.
It's a shape, no? It's a shape?
We're back to.
Well, if you don't know triangle proofs, quadrilateral proofs are gonna be a pain in the butt.
We're back to elementary school. learn about shapes.
I don't know either, so that's nice.
Well, not necessarily. It's more so
Shapes in
you just got to be able to prove a triangle's congruent. And again, like I said, Delta Math is a pain in the butt. And on the test, I literally do not make you write one from scratch. So Delta Math makes you write one from scratch. I don't. I usually give you like most of the statements and most of the reasons, and I have you like fill in the blank.
It's the craziest thing you've said today was very cool. That we can add. But is it?
I don't know. I didn't cuss.
No, I don't know. You could say some outrageous thing when you're not at school. I don't know.
I could never do it. Like, when I told my